In order to perform the rate of return analysis for multiple alternatives, we must follow the series of steps that are listed on slide 6-12. One of the steps, step number 3, requires us to determine the delta I star, which is our rate of return. But in order to do this, we must perform linear interpolation. Okay, so we will have 2 points, one positive and one negative, and we must find the point between them. That is interpolation. So in order to interpolate, we do linear interpolation. We will be using the following formula. It's going to be y minus y naught divided by x minus x naught. This is set equal to y1 minus y naught over x1 minus x naught. If we have the coordinate plane right here, you will have your y-axis and your x-axis. For the purpose of the class, we will be making the y-axis our interest rate and the x-axis the money. Okay, so you can also do that the other way around. Like I said, for class consistency purposes, we're gonna go with I percentage is the y-axis and the money would be your x-axis. Okay, so in a rate of return analysis, we are looking for the rate of return. Okay, so in this case, we are looking for a point in the y-axis, because that's the one that we have as our interest rate. We need to find a point in the y-axis. So therefore, we are looking for y. So we need to solve for y. So this formula will become, after we move the denominator to the other side and the y naught to the other side, we will end up with y being equal to y naught plus y1 minus y naught. These go together inside a parenthesis because you need to find the difference of these two before you multiply it times x minus x naught divided by x1 minus x naught. Okay. The y right here, we said that this is going to be our I star that we're looking for. Okay, so now if we were to apply this formula to that coordinate plane, okay, then again we have the y-axis and we have the x-axis, which is our money. Okay, as I mentioned, we need to interpolate, or we need to find a point between two other points. Once you get to step number 3, you will need to find a positive point. So let's say that we have a point in the positive side, and let's say that we have our negative point up here. The negative would be on the other side of the x-axis. Okay, so we have 2 points right here, the positive and the negative. Let me just point out where they are located. This point right here, the first one, or the positive one, will be our x naught, y naught. And the negative point in the graph would be our x1, y1. Then again, you can do this interchangeably. So for example, the negative one can be your x naught, y naught, and the positive one can be your x1, y1. For convenience purposes, when you plug them into this formula right here, since we have some negative signs right here, this is the best way to have them. Okay, then again, if you interchange them, so let's say like you swap the coordinate, that would also work. It will give you exactly the same answer. Okay, but then again, for convenience purposes, this would be the best way to do it. If you are to swap them, just make sure that you have x1 with y1 and x0 with y0. Do not combine them. Do not have x1, y0. Okay, so it's x1 with y1 and x0 with y0. So here, if we were to draw a line between the 2 points, because remember it's linear interpolation, the point that we are ending up with, or the one that we want to find, is the one that intersects the y-axis. So this right here will be the point that we are looking for. This point right here will be our x, y point. Or we can also say, you know that the x, what's the value of x? Well, it will be 0. So this point right here will be 0, and the y would be our I star.